surrounded by water, and cells themselves make up 70 to 95% of water. Cells are the basis of life, therefore water is the basis of life. The compound of water is key to what gives water its unique properties. Water is made up of one oxygen element and two hydrogens. The oxygen is a very electronegative, meaning that it pulls electrons from the hydrogens, giving it a partially negative charge, and the hydrogens to have a partially positive charge. This unequal distribution in charge makes water a polar molecule. The ability of water to form bonds with other water molecules and other compounds plays a role in its importance. Water molecules form hydrogen bonds with each other. The partially positive charge of the hydrogen bonds with the partially negative charge of the oxygen. This is what is very important in the liquid and solid forms. In the liquid and gas form, these bonds are very, very weak, and they are constantly breaking and reforming. In the solid form, however, these bonds are intact and very stable. The hydrogen bonds are what allows ice to be able to float on water. The hydrogen bonds keep each other at arm's length distance and make far enough apart to make it less dense as a liquid. Some of the other properties of water that are key to life are the property of cohesion, adhesion, the ability to absorb large amounts of heat, and the fact that it's denser as a liquid than a solid.
In general, as things get colder, they contract and become more dense or heavier. On the other hand, as things get warmer, they condense and become less dense or lighter. This idea is true for most solids, liquids, and gases. If this were true for water, this would mean that in a lake or pond, it would freeze from bottom up, preventing life from occurring for all organisms. However, water has a specific property that prevents this from happening. At 4 degrees Celsius, water actually expands and becomes less dense, allowing it to float above warm water. Water molecules in a solid form expand and are further apart from each other, making the solid less dense. Here at our pond, ice is floating on top of the water. When this happens, this encloses the pond, preventing the water beneath the ice to never reach a temperature below 4 degrees Celsius, allowing the fish beneath the pond. This consistent temperature allows for the maintenance of life to continue on even as temperature changes. However, water has a specific property that prevents this from happening. At 4 degrees Celsius, water actually expands and becomes less dense, allowing it to float above warm water. Water molecules in a solid form expand and are further apart from each other, making the solid less dense. When this happens, this encloses the pond, preventing the water beneath the ice to never reach a temperature below 4 degrees Celsius. So in this pond, the fish below it are still existing and living. This consistent temperature allows for even the maintenance of life to continue on even as temperature changes. Usually solids are more dense than water, meaning when placed in water, they will sink. On the other hand, ice is a solid and will float when placed in water.
Stratification is the splitting of layers within a lake or pond due to different densities of water. During the winter months, the cold water stays at the top of the lake while the warm water is on the bottom. When the temperature warms, the cool water on the surface of the lake or pond cycles to the bottom. Thus, nutrients are exchanged between both layers of water. Stratification has the biggest effects during the summer months and the fall months when there is a significant change in temperature. This cycle of the warm water and cool water replacing each other is called turnover. This model of boiling water with tinfoil shows the movement of nutrients in the water. Some of the tinfoil is floating to the bottom and some is floating to the top, representing the turnover within the lakes and ponds.
An article reviewed in 2014 by Yoshiki Komuro tries to replicate how changes due to global warming have affected stratification in the Arctic Ocean. What they found is that due to increased salinity within the Arctic Ocean, it is affecting the thickness of the ice layer, leading to troubles with the ice melting, thus not allowing nutrients to mix with